Hello, so I'm going to talk about our code for the facial recognition project. So the steps for our code is we first align all of the pictures, then we crop the pictures, and then once we have all the pictures cropped, we're going to use those cropped pictures and take data from those pictures and compare them with one another. So our first step to align the photos, we have this folder called alignall.py, and what it does is it takes an input directory called humans2. This is the data set of just regular pictures that we're using. And what it's going to do with those is it's going to find all the pictures that end with JPG, which is every picture in the folder. It's going to output those pictures into a folder called aligned. And what it's going to do is essentially it's going to take every picture from humans2. It's going to align those pictures, and then it's going to output it in this folder called aligned. And the way it aligns the pictures is it takes the two eyes from the photos and it makes the eyes horizontal with one another so that the face is perfectly aligned. And then it's going to output them again into this folder called aligned, and you're going to see that the pictures are all aligned. So after we align all the photos, we're going to crop the photos. So in this program called picture.py, after we align all the photos, we call this method right here that's commented out called crop face. It's commented out because all the pictures are already cropped, so there's no need to run it. But I'm still going to walk through the method. So crop face is right here. We're going to set the dimensions to 500 by 500. Originally, I was going to do 128 by 128, but I wanted to make the photos larger so that I could physically see the differences between the photos that we were using. So I decided to go with 500 by 500. And then what we're going to do in this method is we're going to go through all the aligned photos in the folder aligned. We're going to take each photo out of this folder called aligned. We're going to crop it and resize it. You can see we resize it right here to the dimensions that we want. And then we're going to save that into a folder called cropped. So you can see that all these images in here are now cropped. So to show you what they looked like before, so this is what they looked like before, and then this is the cropped picture after. So essentially what we're doing is we're just taking the picture and just taking out the face, because that's the only thing that is important to us, is the person's face. And again, another example, you can see this is the aligned photo, and then we crop the photo just so we have the person's face. And after we crop the photos, we're actually able to start getting the data points. So we're going to use all these pictures in the cropped folder, and we're going to run two methods, one called eye_dist_all, one's called mouth_dist_all. These operate relatively the same. One's for the eyes, obviously, and one's for the mouth. So before we run the code, I'm actually going to walk through both of these methods just to kind of show what we're doing. So the first one, eye_dist_all, going to go through every file in the cropped folder. It's going to take out the image. It's going to plot the coordinates of the face. In this case, for the eyes, we're only concerned about two points, 0.39 and 0.42. So 0.39 is going to be this point right here on the left eye. 0.42 is going to be this point right here on the right eye. So once we get those points, we're going to save them into two tuples called left eye and right eye. And then after we get those data coordinates, we're going to do an equation right here to calculate the distance between the two eyes. And then once we get that distance, we're going to append it to a list called data. And we're going to do that for every photo or every file in the cropped folder. So there's about 500 of them, so it's going to run through 500 pictures. And then after we go through all those pictures, we're going to take that list data that contains all the distance values, and we're going to change that into an NP array called data2 right here. And then after that, we're going to run k-means with 4 clusters on that NP array called data2. and then we're going to plot all the points. We're going to name the title of the graph distance between eyes, because that's what the data is representing. And we're going to show that graph, and we're going to print out the clusters, centers of the different groups that we get. So why don't we go ahead and run this program. Again, it's going to go through 500 pictures, so it's going to take a while. You can see it's going up by one every time. That shows that it's going through each file one by one. In a second, it's going to show the graph. So this is the k-means graph that we generated. You're going to see there's 4 different colors. Each color represents a different group. So this yellow group right here is the largest gap between the eyes because it has a higher number. And then the next group after that, the light blue group, the gap between the eyes is going to get a little bit smaller. And then the distance between the eyes in this blue group right here is going to get even smaller. And then once we get to this red group, the distance between the eyes is going to be the lowest compared to the other groups. So now that we have this graph, we can kind of look at the pictures, one picture from each different group, and kind of see if the program worked correctly. And to do that, I have these different pictures right here. Let me just pull them all up. So the first picture is from the largest group, which in this case would be the yellow group. And you can see that the gap between the distance between the two eyes is relatively large. So let's look at another group to kind of compare them. So let's look at the second largest group. This picture is from this light blue group right here. You can see that the distance between the two eyes gets a little bit smaller from the last one. Then this picture right here is from the blue group. Again, you can see the distance between the two eyes gets even smaller. And then this picture right here is from the last group, the red group. And you can see that the distance between the eyes is even smaller than the previous pictures. So this kind of shows validation to our code for the distance between the two eyes. Next, let's go look at the next method in our program, the distance between mouths, or the distance of the mouth. So we're going to look at this next method right here called mouth dist all. This is going to give us the length of the mouth to kind of compare who has larger mouths and who has smaller mouths. So this method is going to be very similar to the eye distance one. It's going to do basically the same thing except just with the mouth. It's going to go through every picture in the cropped folder again. Instead of using the eye points, it's going to use the 2 points on the mouth. So let's pull up a picture. So the first point, point 48, is going to be this point right here. And then point, was it 54? Point 54 is going to be this point right here. So once we pull out the picture from the cropped folder, we're going to get those 2 points, save them into 2 tuple values again, and then we're going to do the same equation to get the distance of the mouth, and then we're going to append that distance into a list called data again, and essentially we're just going to do the exact same thing as we did before. Make that list into an NP array. We want 4 clusters, so we're going to run k-means on that NP array. We're going to plot the data points. We're going to call this one length of mouth because that's what the data is representing. And again, we're going to show the graph and print out the clusters as well. So we can go ahead and run this. Again, it's going to take about a minute or so because it has to go through all 500 pictures again. And then once it's done running, we can look at the k-means graph and then kind of compare the different groups again. So you're going to see we get another k-means graph. The values on this one is going to be larger than the one on the for the eyes. That makes sense because the mouth is going to be a larger value than the distance between the two eyes. So the first group up here is yellow. This group represents the group with a larger mouth. The group after that, the light blue group, is going to represent a group with a slightly smaller mouth than the last group. This blue group, their mouths are going to be even smaller than the last two. And then this red group again is going to be the is going to have the smallest mouths out of all the groups. So now that we have the k-means graph, let's actually look at some of the pictures. So the first picture, she is from the first group, the yellow group up here. So she's going to have the largest mouth of the four pictures I'm going to show you. You can see she's got a relatively large mouth. Let's look at the second picture. She's from the light blue group. You can see that her mouth is a little bit smaller than the previous picture. The next picture, he's from the blue group. You can see his mouth is smaller than the previous two. And then the last picture, you can see that his mouth, he's from the red group. His mouth is the smallest of the four pictures that I showed.